Hello, hello. Welcome everyone to the stream. We are starting, and to not make things awkward, I'm gonna start by inviting my amazing special guest. Piotr, are you ready to join me on the stage? Thumbs up. Okay, nice. Welcome, Piotr. Welcome back to the stream, to our amazing AI-related stream. Before we begin, of course, a small round of introductions and of explaining what is happening here, what's going on the stream. So, my name is Kevin. With me today is Piotr. We both work at Callstack, and this stream is a continuation of a stream we had a couple of weeks ago. I would even say a month, maybe, where we wanted to discuss how to train your own AI model, where to begin, how to start. But overall, the discussion became so fun and interesting that we managed to do a lot of side quests, a lot of derailing the topics, and we discussed so many things that we had to do a part 2. So welcome everyone to the part 2 of how to teach your own AI model. What should you build first, how to build it, but most probably, as the story has proven multiple times, when I stream with Piotr, the discussion covers so much ground that there is a slight chance that you will leave today's stream with a knowledge about astrophysics, thermodynamics, maybe some social psychology. But yeah, Piotr, welcome back to the stream. I'm very happy to have you. Before we begin,
it's lovely. It's lovely to be there with you, and I really enjoyed first part.
Oh, I had so much fun. It was a blast. So today, before we jump into the topics, and just so everyone knows, I got a tip from Piotr that apparently so much happened, a couple of in between, this week, that we'll have really a lot to talk about. I missed a lot of that because of some personal related stuff, like apartment-wise, renovation-wise. It's killing me. I'm dying. Help me. So yeah, fun things like that. But Piotr, maybe let's start with, what have you been doing this week, and what are those amazing, super cool things you wanted to share?
Oh, I just have prepared one of those to show you. But what I was doing this week, first of all, I was literally amazed by the speed, how the environment is evolving, especially considering the fact that we've got such big releases recently. And I'm talking about Fable GPT 5.6, right? And right now, we are about to witness Kimi K3, Kimi K4, Kimi K3, right? And what's more, we've got, like yesterday or 2 days ago, we've got 2 such amazing and such opposite releases to consider when they can be run, that I'm out of words. I'm literally. First of all, a little background to those who may be not familiar with this thing. I will share with you the basic concept of
Okay.
neural network.
For that, we need to switch the screen and okay.
So to those who were present last time, and also to new viewers today, the neural networks work in such a way that it is processing the signals from the input according to the train waves between the layers of the neural network, and it it is basically giving the output. It is some sort of function, right? That you have f of x, f out of x, and it becomes y. So here is those waves.
Oh, 1 second. So you're cutting out a little bit. So it basically works just like with, let's say, music, right? If you have multiple waves of different frequencies, different amplitudes, when you mix them, you have a signal, like an actual sound created. And it's the same way, you have a lot of those hidden layers that are decoding those signals and basically creating a sound from just an input.
Exactly. And usually those waves are written in a floating point, right? And with like 16 digits after the comma, or even more. And from that perspective, it gives you a lot of precision, a lot of information. And what just have happened, and it is 1.5 days old. Prism ML announced Bonsai 27 billion parameters model, and it is just amazing that a model that used to be run on the data center, right now you can turn on your mobile device. And I'm not talking about some sort of a special edge devices. I'm talking about iPhone 17. And the magic, of course, it is based on Qwen 3.6, 27 billion parameters. But the magic, what they did, they created two variants of it. One is a ternary version that it is using -1, 0, and +1 to describe the wave instead of 0.1, 2, 3, 4, 5, 6, 7, and 9, 10, right? And that overall compresses the model that in full floating point 16 precision, it is about 50, 60 gigabytes into 5.9. But wait, there's more. They even went a step further. They used a binary waves in a 1-bit Bonsai 27 billion model. It is pure magic, because suddenly, like, they managed to kinda tweak the model in such a way that the binary values are everything they need to store information that usually takes very, very precision. I mean, usually 1/1000th of is enough to change the decision. 1/100th, and here we've got just two values possible out there. And
how is this possible? I mean, just a quick question before I will dive with my head into a wrong conclusion. Is this actually a little bit more similar to how human brains work? Because our neurons, they don't operate on floating points. They're just either on or off, right?
Kinda, yeah. It is. Yeah, Kevin,
So
you're absolutely right. The thing here is that they changed how the model is behaving at the very low level, at the level of data pipeline within the construction itself.
So what are the drawbacks? There must be some drawbacks for that, right?
Thank you very
much. Are
much.
There issues with alignment? Are there issues with...
Yeah, the thing is that when you have the original model here, it scores 85 on overall from 15 benchmarks. And the ternary one, it is scoring 80.5. And 1-bit variant is scoring 76.1. So you see, the ternary has 95% of the full precision baseline, and 1-bit has only 90%. But it is reducing. The overall memory footprint on your device by orders of magnitude, right? We are talking about...
Wait. That's the... I feel a little bit tricked. First of all, I need to do my... I think it's called due diligence. It's a responsibility. Hello, Ryan. Great to have you back. I was hoping to see you today. So welcome back.
Me too.
But I kind of feel lied to. I asked you about a drawback. It doesn't seem like a drawback. It sounds like a small consequence, not a drawback, not a catch. I mean, it's a small decrease in overall performance and quality for a huge decrease in, like, it sounds a little bit scary because is this baseline model capable of scaling? Like, what would happen if we would scale now this approach to OpenAI levels?
That will probably just work.
That's okay. So I have so many questions. So I'm gonna let you finish, and then be prepared for a landfall of questions, because it just doesn't sound right to me, like the thing they achieved.
Yeah, usually such low number of bits, it is something that makes the model almost unusable. But they managed to figure out the way with a custom kernels, and that magical part with custom kernels allows for the whole quantization of 1-bit being possible. And the kernel, it is something that is calculated on the GPU level when you are performing the matrix operations.
Wait. Wait. It sounds like if you would basically have a child like of LLM and a facial recognition model. Like, it sounds like they would run a token, an input through the network. Hello, Gregor. Good to hear you. Good to see you. So it sounds like they would put an input, have all of those layers, right? And then they just scan through those layers with a kernel. It's basically like doing a brain scan on a model.
Yeah, that's kind of good comparison. Yeah.
That sounds like if I would have a paint, like a program paint, and I would just take an input and basically draw by just doing black points what I heard, and then the kernel goes through and turns that into a word. That's so funny. That's actually, I wouldn't have an idea how to begin, like creating an actual architecture for that. But this sounds, wow, that sounds.
Yeah,
Well, I mean, it works, right? It works. It apparently works, but it sounds like a dumb idea. It sounds like it shouldn't work.
yeah, usually you are writing kernels only to make your, like custom kernels, only to make processing of your model faster. They are usually not being written to make the model smaller. But here, what Prism ML did, they basically just perform such an operation. And in order to run that whole model, and of course they've got examples of running that on graphics cards. They have examples of running it on iPhone. And by the way, it is very quick on mobile device. And
I mean, it's basically binaries with additional face detection software. Like face detection software works very fast on every device, and now you basically put the face detection software through neural network. It's annoyingly clever. I don't know what I feel now. I feel annoyed and excited at the same time.
Yeah, they basically created custom low-bit kernels in order to do hybrid attention architecture.
Wow.
Yeah,
Wow.
that's so clever. That's so clever. Optimization. How
Customizability.
Yeah,
Like, I mean,
exactly.
you can train one model and then just retrain the kernel, like modify the kernels to have a different behavior, to react differently to data.
Exactly. We can even call that model compression.
Wow, that's, and so did they release a paper for that, or?
Yeah, of course. They have the white paper. We can open it if you want. They also forked Llama CPP with that custom implementation of their kernels. So yesterday, in order to run this model, you had to clone that fork and compile it on your machine, and only after that you could run the model.
Did they release it now, like wider?
Yes, you can use it. You can download it. It is available on Hugging Face right now.
So how is it called?
Bonsai from Prism ML. And I can share the screen here. Yeah. So you see that on Hugging Face, they created a collection of Bonsai 27 billion parameter models, and also you have that web GPU kernels. That those kernels allows you to run it in your browser.
Yeah. Okay. No. Wait. That's let me cool down my head. I have one rule for quite a while now. I don't get on hype trains, and as exciting as it seems, we've been through so many iterations of exciting news, of amazing new frontier models, of everything, and often it turned out to be either happy path of testing or overtraining to fit the benchmarks or whatever. what are actual downsides of the bonsai model? What is the context size? Is it capable to be put like guardrails? And
yeah. Literally, I will.
wait, do I think correctly that you could actually create like embedded guardrails by adding additional security kernel?
Yes.
Like basically embedded into a model, like kernel that will lower the values or increase the values on like dangerous stuff, and just basically do an inner trigger, like a fight or flight response inside the model without the need to put like additional small model for security guardrails and stuff like that.
Yes, and the process that you are describing, it is literally making the network forget.
Oh yeah, because you can basically add like a filtering kernel that will just, it will work like a censorship, like blur that follows the face on the phone.
Exactly. And coming back to your question, Kevin, yeah, this is not exactly a hype train because a lot we have seen in the past situations where the news suddenly break out and we got a lot of information that something should be there and do that or this or that, but it was not exactly the case. But in this situation here, they basically got that Qwen 3.6 27 billion model, which you can see is 53.8 gigabyte in size, and they applied quantization on it. I'm trying to open it very now, of 1 bit that converts it to that size. It is literally the compression that works.
I mean, you can't do quantization. Like like we reached undividable values, so you can't really do quantization on that. And wow, that's
yeah, but that's the magic of that custom kernel. So they usually, like, I will come back to Qwen. If you would like to use that model, right? Usually you are going to that the default option here. If I click Llama CPP, you can see that it is proposing me Unsloth Dynamic Q4K XL. It is one of the possible options because some of the layers are at the higher quality than 4 bits, the important ones, and most of them are 4 bits, right? And it is 17.6 gigabyte. The most commonly used non-dynamic quantization, it is Q4KM, and it is 16.8 gigabyte. And this
can you actually make the screen a little bit bigger? It's hard to see the values.
Yes, of course.
Oh, great. That's perfect. Thank you.
Yeah. And usually at this point, due to the fact that you are dropping 12 bits, right? So you are literally cutting the point of the precision of the values out there, where that's the original model, original quality. So with each step here, you are dropping the accuracy and precision of...
You know what? It kind of sounds to me comparing quantizations to the bonsai model, it's kind of like you have an image, right? And you can do the quantization, basically degrade that image, lower the resolution, and you go from 16 bits to 4 bits, right? But you lose so much information on that. But alternatively, you can also make a very lower level resolution, like lower the resolution a lot, but you just turn that image into a line art. You only have black and white lines, and you have all of the information, all of the data in the image, and also you have a very light.
Kevin, that's just perfect example. Really.
Damn, that's
because what happened here, and so you are going from 16 bits lower and lower. This is usually the last usable one.
yeah.
And this one is about 80, 85, 90% of the precision of the original already. And if you go to 2-bit, it is like 60, 70% of the original model quality. And it's still like, you see, it is still like between 9 and 12 gigabytes.
Okay,
And
so let me ask you this: how bonsai performs against quantized Quen models?
I think they described that in their white paper, and also some of the just give me a small second.
Oh wow! Wait, they also did the bonsai for MLX.
That you can run on Apple devices, yeah. Yeah, so you see, we are talking about that Q4KXL, right? Bonsai. I'm sharing this one. Bonsai compress that using their custom method and custom kernels to operate with that custom data to 3.8, 3.9 gigabyte, right? And you can see that it is still 53.8 in the original. And in comparison, you can see that this is actually a table with memory and the usage according to the context. So so here the memory footprint is much smaller. However, it is still increasing with the context size. And in terms of the quality, let me on policy, off policy, quantizations. There's a lot of information that a lot of information that is very amazing from like my point of view. I hope yours too. And intelligence density, it is 15, page 15. I will load those additional speculative decoding, Yeah, you've got that speculative decoding architecture here. Yeah, and thinking mode benchmarks. This is with the comparison to the original. You see, the original model with the memory footprint of 54 gigabytes. Within that, achieved the score of 85%. It is the original one. Q4, so 4-bit quantization, in theory achieved almost the same thing. 2-bit dropped heavily, but they managed to keep that thinking mode across the compression spectrum just properly. Like, this is out of this world. This is poor maths.
I'm quickly preparing something to show as an example, because maybe not everyone is a visual thinker, and maybe people need some more.
I think we went deeply into low level stuff and technical.
I think people will enjoy the example I'm gonna give. Let me quickly share the screen. So I'm turning your screen down and taking this screen back up. Okay, so this is me, right? This is my photo of me. This is the regular photo, the raw input. And now we have two options. Either here, we basically can call it quantization, right? This is kind of what quantization does. Except for, of course, here we have the same resolution, just adds blur. But if you would, instead of blur, just lower the resolution, at this point, this gentleman here, like you don't know if that's a person, if that's a flower, what's that, right? Because you have very low range of values to use and low resolution, stuff like that. But if you use basically black and white, you can just have a line art and that's it. And you have all of the information you want in that image. And it's, I mean, of course, it's not lossless, but all of the information by the way, it's kind of cool photo. I'm going to use that. So, you can have that. And such a low amount of data required to draw that, because it's black and white, you have 0 or 1. And if you would scan a kernel through that, you can recognize that it's a Kevin. Ta-da, it works. Brilliant approach. That's actually very clever. I think I'm going to post that on my X. Do you think it's a good example?
Yeah, this is a perfect example.
Nice. Damn, but I'm just surprised. Like, there are so many brilliant people working on it's a novelty approach, of course, but how is it possible that no one throughout those couple of years, like, is it tunnel vision? Is it a great example of thinking outside of the box? Because
this is a perfect example of thinking outside of the box.
Because
we try to utilize that quantized models in the same manner as we did with the full models. And what they propose.
But it sounds so much like the thing we talked briefly about last time, about those models that are multimodal, very multimodal, like basically trained on the world. Because when you look at how people see the world, it's not like the image from what we see goes directly into our brain. It first goes through the kernel. So here's the input. There is a processing element, That's super clever. I really like that. So what is the, because it sounds like huge thing. The only thing I could have against them is why did they choose colors like that on their web page? This is a set of most boring and
this one present here is GitHub currently.
No. I mean Prism ML web page. It's
this one. Yeah.
Yes, it's like, honestly, if I would go through that, I would just step on that. I would be like, oh, this is somebody's personal blog. I'm gonna leave it. Such an underdog.
Yeah, that's, they are keeping it simple.
I mean, fair enough. But okay, but what about
we just have dropped a compression method that changes the way you approach LLMs.
Yeah. Oh my god, so it's not gonna slow down, eh?
Of course not. And are you ready?
Oh my god, so you have more news.
I mentioned that I have something that is completely on the opposite side.
So like a huge model? Run thinking machines Inkling locally. That was okay, so Inkling by thinking machines, new model with 41 billion parameters active. So it's a mix of experts model. Yeah. 1 million context window. That's a huge context window. License under Apache. Oh, wow. Okay. Accepts text, images, and audio.
It is first open waves US-based model of such size.
Okay, so US is snapping back at the what was the model? I forgot the model name.
DeepSeek?
Yes, exactly. Thank you. Okay, so Apache, so it's a very permissive. The model excels at coding, agentic tool calling systems, RAG, chat, multilingual applications, and multimodal workloads. Okay, so it's not really that good with like facial detection, generating images, stuff like that. So it's very smart, but not yet.
No,
like
it can accept text, image, and audio, but can generate only text.
Like this. Okay. Okay.
But the magical thing is the size of it, right? Because we are talking about almost 1 trillion parameters model that at full quality weighs 2 terabytes.
Oh, so now they lowered it to 285 gigabytes.
With that dynamic 1-bit and dynamic 2-bit, but you can see that it is keeping that quality drop that we have just described. That's why I wanted to show first Prism and explain the quantization thing. And here you can see that they are able to drop the size to almost 300 gigabytes, right?
Yeah, okay, so is this a case of parallel thinking, or did they actually got help from Prisma ML?
Here, this is example of classical quantization, not any kernel. This is classical quantization. So you can see that using that one dynamic 1-bit, they only achieve 74% of the original quality.
With, okay, and 86% smaller. Okay.
So
what would now happen if they would do the same magic that PrismML did.
Yeah. So if you take a look here, you can see that the size is tremendous. I cannot run any of those on my MacBook.
Yeah, because you have too many models, not enough space.
First one have to download it in order to in order to even try to load to video memory, right? If the algorithm of Prism was utilized here, I think that can, in theory, if they were able to decrease the size by about 92%, so we have an answer.
Okay, so what's the difference? Like, I mean, here we have the Unsloth. So did they just come up with a new way to quantize models, or did they create a new model from ground up? Like, what's the catch here?
Yeah, so we've got models from different providers, and Unsloth is providing GGUFs for most of the models. So that model, that GGUF is based on that base model. So you have thinking machine inkling, yeah.
Mm-hmm.
You can see that like it has 4 downloads last month. I'm talking to you about like this one literally just dropped.
Oh, like literally just dropped. So Juan, who just arrived, hello Juan. So we discussed by now the Prism ML with the Bonsai model, who introduced a new, can I call it a new architecture basically?
New compression algorithm.
New compression algorithm. So they are able to use the network layers, and then they are read by a kernel, which is very exciting and very new stuff.
They are dropping from 54 gigabytes to 4 gigabytes basically, and you can
but
run
it's kind of it kind of sounds like an approach that would benefit from increasing the amount of layers, not adding bits to the tensors. Tensors, is it a good call? Is it a good word for that?
Tensors are basically vectors in machine learning.
Yeah. So I meant neurons. Yeah, it sounds like they would benefit more from scaling the amount of layers and not increasing the neurons capacity in terms of, because what does it mean, the 16-bit? Because it kind of contradicts the thing they are bragging about.
No. Here we've got once again GGUFs. So those are the conversion way different variants of the model in terms of the quantization used.
Yeah, but how do you quantize things when they already have 1 bit?
Originally not. Originally it had that 54 gigabytes.
Oh.
Yeah, they went from that 54 to 4.
Okay, now it makes sense. Okay, so it's basically like somebody announced, yo, we just came up with a zip or rar for models.
Yeah, we just have witnessed a new zip.
So can we hope that GPT 5.7 will be super cheap? I mean, it sounds like something people will actually switch towards, right? Like I can't really. So Juan asks, can I run it locally? Is it good for everyday quick response like WhatsApp app bot? So it's still worth keeping in mind that it still performs at a levels of quantized bigger models, right? So the thing that is crazy here is that it's we are basically excited that a patient after a lobotomy still can do math. So
exactly.
we found a new way to perform lobotomy on the model, not to damage the most important parts.
So answering your question, dear viewer, Juan, right?
Juan, yeah.
Yeah. If you know Qwen 3.6, which is basically a very good model on its in terms of its size and capabilities for local AI, they converted Qwen with a completely new method of conversion of compression. So yeah, it's you can basically set up a whole local AI ecosystem on top of it, and it just works.
And it's just the beginning. So I would assume that in upcoming, okay, I'm gonna play Nostradamus here. I predict that in upcoming 2 to 3 months, you will get an option to run locally on your laptop, not yet on the phone, but on the laptop, models that are quality-wise just like the initial GPTs that became such a big thing. Unless I'm completely wrong and current Qwen models are better than initial GPTs.
I think we are past that.
Okay. So like newer GPTs. So, but I think honestly, it sounds a little bit more exciting that maybe the models will get cheaper. Maybe we'll have some cheaper tokens, which is also pretty good. So that's super amazing news. I'm excited and scared a little bit. But well, that's a constant state we've been in for a couple of years now. Am I right?
I mean, the thing here, like, I started describing that kind of model sizes that some time ago you needed a data center to make inference of such a model. Right now you are able to run it on your iPhone. So we went from data center to desktop to notebook, and right now we are at the mobile. So,
but how to say that, the fact that they came up with this, it's amazing. Wait, Juan asked one more question. Should we be able to reliably run on React Native high-end devices and like make combined with local versus SQL to have app scoped harness? Yeah, why not? Totally. So it runs, it performs, it has a nice quality, but the problem that I see here is that, like with local models, because for quite a while I've been excited. I was thinking that, maybe there will be Siri 2.0, right? Because Apple was cooking something. But then they didn't. And the problem is adapting that to actual, because Prism ML, they don't have any clients. They can just release amazing technology, amazing findings, and just be proud of that. And that's it. But if you're a company like Apple, you cannot just ship your devices with AI that works like 70% of time. The other 30, it might ask you to go and do something bad to yourself, right? And if like they need this guarantee, they need the quality. And so yeah, I think it's amazing news, amazing technology, but it will take some time before we see bigger benefits from that. I think I might be wrong. I like being wrong in those kinds of things.
I estimate it's about a month
till we see like cheaper tokens, or
till we see that such a technology will be widely used.
Okay.
The same thing was with speculative decoding. The same thing was with NVFP4. You seen that it was released at some point. That basically was just a method that changed the way that inference or quantization works. And right now you have NVFP4 variant of all the models. And right now you have speculative decoding assistant models for all the new release models. It is a matter of a month.
So to rephrase that and maybe switch to a different topic, maybe to rephrase that, new findings in quantization technology is basically making you like you can ship your model, but now you have to ship it with a custom made like magnifying glass in order to like for a model to work. Because previous quantizations, they were just like taking the model, like, oh, we don't need that, we don't need that, we don't need that, done. And you can run it in the same way. You don't need to change anything in your setup. But with the new way of quantizing, you basically need, you can't just like have a model. You need to have this special little device in order to read what's happening.
So right now, in order to utilize such quantized version using that 1-bit compression, you need to utilize the forks of inference servers that contain implementation of it and understand how to decode the model written in such format. So we will have to wait till that become widely adapted, right? So till changes will be merged into the most commonly utilized inference servers. So right now you have to build a special Llama CPP to run Bonsai, but so, in a matter of week it will be merged.
I love comparisons and I love metaphors. And to use a metaphor, we've just seen a first Tesla. And yay, everyone is excited. Tesla car, wow, electric car, and it's able to ride. And it's using exactly the same roads as every other car. But, well, it's not really that useful until you'll have like infrastructure to charge it every X thousands of kilometers and stuff like that, right? So what we wait for now is an infrastructure to be able to use that model everywhere. Because like when you told me that, first thing I did on my side screen, I checked if it's available on OLLAMA. But they cannot just like release a new OLLAMA model because they are not being, you cannot run inference with exactly the same things.
Like OLLAMA is not ready yet.
Yeah. So, but as you said, if they manage to rewrite Bun in a couple of weeks, if I remember correctly, I guess that they would be able to improve and modify those models to actually. That's amazing. So yeah, a short summary. 2 new amazing informations. First is Prisma ML. Check it out. Very small model that's using just 2-bit neurons. And second thing is Inkling, a very new, fresh, huge model. But we are finally reaching, like, wow, maybe in a very soon future, you would have local distributors of LLMs. Like, maybe. Instead of paying to OpenAI, like, oh yeah, my neighbor has like 2 servers and he's able to run this like huge model with great capabilities. So wow, that's very interesting. But yeah, I can see that. Yeah.
Like, for example, if I remember correctly, today I read about a company that is providing, in cooperation with AWS, they are providing you a container with whole HWS that can run locally. You just have to plug it into power, and you have AWS at home, or your company, of course. Yes, a small data center in a container that you set up in 10 minutes.
It's happening too fast. Like, yeah. I feel like the throttle has been punched up again to the maximum. But yeah, that's overwhelming, but also scary.
I would say that the more important, I would say that the most important here, that models will become smaller and faster.
Yeah.
And therefore,
and here is where I'm getting off the hype train, because models have been getting better, faster, and cheaper for like every day for like 3 or 4 years now. So that's where I come off the hype train. From users' perspective, nothing's going to change except for maybe pricings will go a little bit down. Maybe the speed will go a little bit up. But with me getting off the hype train, it's time for me to share the screen, because we are going back on the road, baby. We went through all of those things, guardrails, fresh LLMs, and then plenty of other topics. And we finished on what's the most expensive training mistake you've heard of, and what are common beginner mistakes. I think we finished here, right? Or maybe here. Yeah, let's say here, the common beginner mistakes, because let's put me in shoes of, I want to train my own model as a beginner. What usually where do people fail usually at this point?
Either data distribution, or not properly formatting the data set to make it usable and valuable for fine tuning. And by that I mean,
okay, so let's say I like to operate on an example, right? So let's say that, I want to create a model that will act exactly like me. So if I need a model to act exactly like me, all I have to do is just copy and paste all of my messages I've been sending to people on all of my chat applications, And while I have a great data set, right? I have input messages and my responses. Isn't that enough to train a model that will act just like me?
It depends mostly how you format the data and how you format those examples, because in order to make model more familiar to you in terms of the format here, you would have to put into its memory a lot of samples divided with the sizes properly, and that size also is important. I mean, there's a lot of factors: the size of the model, the learning rate you are using, if you are using full fine tuning or LoRa or QLoRa. So there's really a lot of factors. And
okay, so I assume that the most beginner mistake in that scenario would be that I don't modify the dataset at all. I don't even look at it. I just do copy, paste, and run the training algorithm. So I assume I would achieve bad results because my assumption would be me as a person, I'm not every day in exactly the same mindset. So I bet that if you would take all of the messages and there would be like 10,000 of people saying just hi, and me responding with very varied, like in very varied ways, right? So this would basically break the training because it would have plenty of examples of input being exactly the same and output being like completely different. So okay, I would summarize.
That's just perfect example, because
so let's say that continue. I'm gonna read.
I mentioned about data distribution, right? And the situation that you just have described, it is example of unequal data distribution, because you've got a lot of conversations, you've got a lot of different ways the conversation continued, and you've got a lot of highs. And if you treat those high messages separately from the conversation, so that's the case you described. You just get the data. You are not looking how that data is being processed during the fine-tuning, and you just throw it at the model. And suddenly, the framework of yours is dividing that into separate messages that being trained for the model. You are thinking that it is training the model on hi, answer, your answer, your follow-up, second answer, and more.
But that's what we would call a fine-tuning. So teaching model how to properly operate in terms of conversing, but we're starting from lower level, right? So it would split all of the messages that if I say I am, usually I say angry or annoyed, and then. So it's gonna make a lot of chunks. So be mindful of data at samples, and also be mindful of the data set there is a word for that, right? That there are those steps in training that are making sure that all of the data inputs are formatted in exactly the same way. Pre-processing, just that.
Yeah, pre-processing.
Be mindful of data pre-processing that is implemented inside your training framework, or how it overall it's done. So okay, so the most common beginner mistake is underappreciating the value of a data set. So people think that, oh, I can just take all of my messages and that's a great data set. Not really. Might be, can be, but it's not just copy and paste. It requires a proper. I'm losing words. There is this nice word. Yeah, just pre-processing, preparing the data, because you cannot train a model by throwing everything you have. Everything needs to be in the same format because it's input, output. If you have input with many shapes, you can't expect output to be reliable.
And I would say that something useful for our viewers would be make yourself familiar with data engineering.
Oh, learn data. So, in my understanding, data engineering is basically Python full. It's learning how to use Python scripts to modify the data in a matter of seconds. Like, oh, I would come and be like, here is a bag of words. I copy and pasted this book, turn it into a data set. So data engineer would be able to take that data and, for instance, remove all of like special characters and get rid of page markers because you don't need them. And you would basically take the PDF of a book and modify it into a great set of strings prepared for training.
Exactly.
Okay, so learn data engineering. This is basically like a prep, data preparation, data engineering, because it's data preparation, and learn English. Okay, because basically data preparation and manipulating data, and that's data foo. It's basically like saying if you want to start boxing, do cardio as well, and learn how to like lift weights before you start doing crazy stuff with your body. As I said, sorry, I really like metaphors. And hello, Infinity. I was really crossing my fingers that you will join us. So hello back. But I think we covered that nicely. So be mindful that it's gonna be a little bit harder than you expect, but not as hard. So the second thing is, do you actually need millions of dollars? Because let's say that, oh my God, I don't have enough time to learn data engineering. I have games to play. I have figurines to paint. Maybe I can buy a data set to like start working.
There's a lot of free data sets that you can get from Hugging Face, from Kaggle, that allows you to train any model in a certain way. And of course, that data influences the task, right? Because you always need proper data for the task you're about to perform.
So I'm gonna say that not to start learning. No. To start learning. Yes. To make products. Because if you want to start just learning, there are plenty of free data sets to start learning, to start actually creating the models. On Hugging Face, right? They must have some nice data sets, like 101, because so to start learning, yeah, I think you could even take books from Sherlock Holmes. I think that there are available Sherlock Holmes books online that are already their licenses got Creative Commons, so you can get them. And why not preparing a model that will speak like old English folk by preparing this data set. So yeah, there are plenty of data sets to start learning. But if you would like to have a model that speaks Gaelic, maybe, I'm not sure if there are plenty of sources for Gaelic. Maybe you would need to pay someone to create translations. Maybe you would need to pay someone to give you some nice data or stuff like that. So do you think this is a valid response, that no, if you know what you want to do, yes, if you want to do something very specific?
This is proper one. Moreover, I will very quickly.
Infinity mentioned that I did some Kaggle competitions long back for data engineering, and that's a great way to start. I actually started my programming adventure with, there was the coding game, I think that was the name of the platform. So that's a great way to actually apply and start learning, because of course we are living now in a day and age where you can just ask your model to pre-process the data in this and that way. But what way? I mean, you can have machines that will do a lot of things for you, but you are the driver, you are the operator. You need to know what you want to do with the data. You need to plan accordingly. You need to have understanding of what you want to do with the data. But yeah, Kaggle would be great. I see you are sharing a screen. Should I put it on stage?
You can show it.
Okay, I'm showing the.
Like if you want to train a model to behave like Sherlock Holmes, and you even here have a system prompt here. I want you to act like Sherlock Holmes from Sherlock Holmes. So you have all of that knowledge to make the model sound like that. And even you are able to put some kind of the Easter egg of the instruction at this level. So for example, your catchphrase is elementary, my dear Watson. So you can make the even at such a level a guardrail.
Right, because you're basically performing an open brain surgery on those base models, right? So you can turn them into something they weren't previously. So okay, let's say we have a data set from open source. So we can start learning, we can start training. We learned how to prepare the data, how to create strings that will be inputted into the framework. So now the question is...
Yeah, I will stop sharing and we can come back to your screen.
What can a single developer realistically train today? And it's can I just God damn it, it doesn't work like this. Oh, it does. Here, nope. Yep. Okay.
I kind of liked what just happened because that was also partially the answer. You as a single developer right now, you're able to train small models as well as you can train large models. And it is just a matter of the amount of data you have and where would you like to run that model. after you trained it, because you can rent a GPU at any of cloud providers for just plenty of, I don't know, 2-3 hours and train your model. But the question is, where are you going to run this model? On desktop, on notebook, on mobile, or you have a home server or home lab server?
So let's say
that's
locally on laptop.
Yeah. So
actually, that's a very, very good point. I think we didn't mention that. Having a device capable of inference, it doesn't mean that you have a device capable of training the model. I remember back in the days when I was playing a lot with Stable Diffusion. And I remember my first time I almost had a heart attack because I prepared everything. I was like, ooh, I'm just going to train my own model. It's going to generate me. Wow, that's going to be so much fun. I press start and my machine made a weird sound, displayed just a blank page and froze and died. And I thought I killed my machine, so I had to restart everything. So when you are using frameworks that will be training your model, if you don't have that in mind, that you have limited amount of RAM, of epochs, of time, of processing power, it can really easily just jam your entire processing power and just freeze your computer, and that's it, right? Because inference, it's just you take a string, you figure out what's the next token, you take those 2 tokens, you figure out the 3rd token, you take 3 tokens, you figure out the 4th token. But with training the model, you're basically doing this, plus you are doing this on couple of threads in the same time, because training a model on one single thread on one conversation, I think it would be virtually impossible. And not only you are doing this.
Would you like mathematical answer to the difference in size?
Yeah.
So basically, for inference, you need a space for model and space for attention.
Wait, I think that's gonna be model plus attention. Yeah. That's for inference.
Yeah. And in terms of training, you need space for model and optimizer, where optimizer is like size of the model squared. Yeah.
I'm not sure if I can just do this with something. Can I modify it? Can I edit it? Nope. Sorry, I thought I'm a little bit better with Excalibur. So that plus optimizer, which is you know what, plus model squared.
Yeah.
Plus model times model.
Yeah, exactly.
See, I speak math. Model plus, yeah, so that's a lot more. Wait, Infinity asked a question. What happens over the period of inference continues? Won't be, what happens over the period continues? Oh, yeah. I mean, not really a memory leak, but isn't this exactly what happened with the security woman from Google or Meta? That she basically ran the model and it started running, but she was not able to cancel the process. So it would be actually with incorrect model preparation. Let's say you have a fresh model, right? That's just doing inference. It is realistically possible that it would just start spitting out words and eat up all of your memory for context and crash your computer, because it's going to be like, now I am preparing a new sentence. This sentence will be na. But nobody taught this model to use a stop token or a pause token or end of message token. So you can just like blubber, 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 blubber. The context window will get bigger. So without like that's one of the things that those frameworks to run the model inference do. They, for instance, take a chunk of your memory and they keep the model from taking more memory than it needs. Not really. Rarest questions would fry GPUs. Not really. At some point, the memory of GPU would get overflow, and basically even your PC wouldn't be able to process graphical input from your mouse, and everything would just clog. That's why sometimes when processors get out of hand, you experience that as a window getting jittery and stuff like that, because your processor or GPU is doing a lot of processing in the background, and it doesn't have time for something silly like your input from the mouse or displaying stuff for you on the screen, because it's processing the stuff. So most probable scenario would be that after some time you just need to hard stop your PC, because it wouldn't even have enough processing power to get input from you to stop the processes, to restart. That's why you would need a hard switch, be like, nope, sig kill basically. But even sig kill has to be processed. Although I think that in bigger processing units, sig kill might have a special, like, small processing unit. Am I completely hallucinating now, or am I right? I feel like there are some safety measures in place, but overall, yeah. Just because your machine can do inference, it doesn't mean that it can run training, because training requires your machine to not only take input, generate output, but also verify the output, compare it to what you wanted to achieve versus what you got, and then refeed everything. And I think it's kind of important to now mention that's one thread, right? So this would be like, let's say, a couple of times.
Maybe. Yeah, in terms of the batch size, a little, but I would keep it single.
I mean, yeah, because you load the model once, but then you does it work basically like a contract in database, that you take all of those changes and then after an epoch you just change everything?
You are doing that every batch.
Oh, okay. Every batch.
And within a batch, you can have 1 sample, 2 samples, 4 samples, 8 samples, 16, 32. And out of those, let's say 32 samples within a single batch, all of them are processing in parallel. The the average change is being calculated and put back into the model. And the next batch is working on a model that is already altered by the previous batch.
Yeah. That's what makes it gradient, right? So without that, you would have a lot of small changes, but they don't gradually increase and modify the model. By the way, that's why we use snapshots, because sometimes you can have this change, right? You have a model, you then have a little bit different model, and then you have even more different model, and at some point you overtrained and your model looks like this, and you're like, oh no, I really liked how it worked a couple of epochs ago. Well, thankfully, that's why you have snapshots. Very useful thing. Also, I think it's maybe there is a, what's the next question? When should you train the model versus use an API? Okay. Okay. I think this would be a good place to actually mention one thing. Let's say that this is a model. And okay. By this is a model, I mean that here is the input, here is the output, and here are those like millions and millions and bazillions of connections that just do stuff magically. What usually happens when training the model, if I understand correctly, we don't always train entire thing. Because if I remember correctly, usually training models is just modifying the last couple of layers, right?
That depends from the architecture, but usually in terms of the like classical language models, not generative ones, in order to make it work in a certain task, you're just training the switching head. So you are just training.
So this layer.
Yeah, this one. Yeah.
Because basically, not sure if everyone remembers, there was this nice example with how visual models recognize things. At first, oh, that's a line. And oh, from those two lines, oh, that's a shape. Oh, from those two shapes, oh, wow, that's an eye. And from those two eyes, oh, wow, that's a face. And kind of similar thing happens in the model. Like here first, oh, those are words. And those words mean things. Oh, when you connect those two words, they mean something different, and they can make like they can connect, like bad apple and good apple mean different things. And oh wow, now if we add even more words, we have a sentence, and the sentence have a meaning as well. And at this point, we can communicate through sentences, and they have a meaning. And at this point of layer, this last layer is something I think we could call personality, or like more focused, the point of a model. Like what's the meme? Goddamn it, the meme from Rick and Morty. What's my purpose? You pass the butter. So that's the purpose layer. Of course, it's not an official term. I just and of course it's very simplified, but that's what training the model means. We modify how it reacts to stuff, but we don't that's why sometimes we can use different base models depending on our needs, because we get that because nobody has enough money personally to train that. You get that out of the box. We just train our own like flavor of that model. So Sorry, I like to, I like examples so much. If at some point people will start shipping actual robots, right? All of us will get exactly the same robot with same capabilities, but everyone will then train the last, like, purpose. You pass the butter. So yeah, sorry. I just thought this will be a nice moment to push that in.
This is kinda perfect, and I was when you were talking about this, I was searching for that example where you can this thing that you presented here is all right in terms of like classical models. I mean, in terms of
oh yeah, because yeah, models with attention have a little bit different structure, right?
yes, exactly, and that's kind of why you have to remember that for language models, large language models, you can either train the whole network, or you can do something called LoRa fine tuning.
Yeah, so that's basically putting a different hat on your model.
Yeah.
I really think if you, dear listener, would like to get into LoRa's, start with Stable Diffusion. I feel that Stable Diffusion gives a nice visual representation of what LoRa does and how it works. It's basically, I mean, even in this example, this is like regular output, but you can put a LoRa on that, like call it Linard LoRa, and you have every output in Linard style. So that's a LoRa that doesn't mess with how model behaves. It just changes. It turns the model into an actor. And you can ask an actor to speak with a different accent. So you don't need to retrain entire actors' like personality and character and everything. You just need to teach it one more skill, and that's a LoRa. That's basically a new filter you can put on the model. Okay, so realistically, a single developer, if the single developer has $1 million, he can rent plenty of computing space and teach everything. But locally, you can use small model, get data set on Hugging Face, and and just try to change the model to like speak as a Sherlock Holmes, for instance. And second is, I think that we kind of discussed that already in some way, but when you should train a model versus just use an API. And let's say that I mean, what did I mean when I wrote that question? That was quite a while ago. Okay, let's say that I meant train a model as actually install all of the dependencies and then run Python scripts on your machine to actually train a model, versus use an API, meaning that you just drag and drop a couple of documents into some OpenAI API and it trains the model for you.
It used to work that way.
It's not anymore.
Yeah, like some of the providers dropped possibility to make your fine tunes.
It doesn't sound like a very lucrative option to keep a huge fine-tuned model just for one client. Not to mention loading it into a memory when you can have one model, and then just switch the system prompts and stuff for inference.
I think I have an answer for that. So, if you are able to afford putting the context with the knowledge that is crucial for the task and some ongoing context together, you are able to put it into the context window of the model. You can use a API. But if you have that repetitive context that you have to always put as the knowledge base, or you are not able to feed that knowledge base into a context window, then you can train the model. So you are switching from giving the model context each time to embedding the knowledge into the model and just prompting it with current operation.
Okay. I think that's actually a great answer. I was not expecting that, but that sounded really mean. I was not expecting to understand that answer. So I think at least so well. So to give an example, let's say that those are two models, right? This is one you can run locally. Well, maybe it's a little bit smaller, has less capabilities, but this is a context window, right? And let's assume that you want this model to help you with some very, very niche thing you want to start doing. You want it to be a specialist in recognizing mini figurines, or a specialist in recognizing value of trading cards. There's TCG is recently very popular. So you can, of course, use OpenAI and pack 1,000 examples and pricings and visuals and everything into a system prompt. And this leaves you this amount to actually talk and discuss. Because even if you have a sliding context window and your conversation is huge, then it is going to slide along with the system prompt, basically overriding the conversation. So it's not going to be a nice, pleasant conversation. And you have to leave a lot of memory for skills, system prompts, whatever, because the model just doesn't inherently have information about the things you wanted to have. So instead of doing that, you can take a smaller model, prepare a data set, and then you actually don't need a system prompt because everything that you wanted from the system prompt is embedded into model. It's outside of the context window because it's inside the model. So all of that amazing space you can have for conversation, for talking and discussing why is this card more expensive than this card or whatever. So to answer when you should train a model versus use an API, if your specific niche need is too big to put into a system prompt, because even with caching, even with all of those things, you would basically start every conversation with a couple of dollars overhang. Maybe not dollars, but cache hits are less expensive, but still you would start each conversation with a huge system prompt or skill set for your model to recognize your need. And at that point, it's better to have a little bit dumber model, but trained for your exact need or purpose. Does it make justice of what you said, Piotr?
Yeah, exactly. And that's a perfect visualization, Kevin.
Okay. Thank you so much. I'm glad I'm able to understand what you are saying. I'm basically taking your answers and I'm parsing them into dumb speech, because I feel like everything AI related, it's just like with lawyers. Like, law is not that complicated. What makes it complicated is all of the magical words and language barriers and everything.
I 100% agree with you, because I'm completely aware that I can be biased due to the fact that this is the language, this is the knowledge that I operate on daily basis. So for me, certain things or even terms are straightforward, but if I did any sort of a shortcut in thinking, yeah, that could be problematic. So, Kevin, thank you very much for translating.
Well, to be as transparent as possible, I have never trained a model. I am fascinated by this technology. I love to learn about it and explore like my understanding of how it works. But just because I can talk with someone about cars, for instance, and this car has this like an engine and this engine has this capabilities and this is how it works. But if you would give me a hammer and a wrench, I'd be like, fix my engine. I'm like, I don't know how. So yeah, I can talk about AI all the time, but I've like my practical knowledge, it's very limited. So actually, this question is also for me. If I would like to learn how to train models, what projects would you recommend for beginners? And by projects, I maybe mean, you know what? I think I used to ask you this question before, and you already answered me. And I think your answer would be related to Mr. Andrei Karpathy. Am I wrong?
Yeah, you are right. In terms of deep understanding what's going on and what you are really doing, this is perfect.
Yeah, exactly. Infinity caught that. Yeah, micrograd and nano GPT.
Yeah.
This is the best place to understand how things work, but in the same time, it's kind of like learning electricity and understanding how you can connect two cables to have a light bulb flash, right? So yeah, I understand electricity. Yay me! But and maybe simple boards, I understand. But then from nano GPT or micrograd to actually, like, there are so many skill gaps that in theory I understand, but I wouldn't know where to begin. So even with micrograd and nano GPT and all of the knowledge that Andre is sharing, and I think is one of the top quality, I think they should actually use it as in schools as example, like but just because I understand that. Let me put it this way. Just because I know how to start a car and drive and stop and get out of the car, it doesn't mean I know how to drift. It doesn't mean I would be able to finish a racetrack, right? Mm-hmm. And that's how I see it. I understand how models work, how you train them, how layers work. But if I would like to train a model, because for stable diffusion, there are well-known huge frameworks that are created with Python scripts that you basically open up, you check boxes, you provide your dataset files, run start, and it trains your own LoRa or your own small model for generations. Are there any things like that for teaching your own model? So your LLM.
Yes, in terms of LLM. But if you don't mind, I will start answer directly to the question and come back to LLMs. Okay. So first of all, think about the problem that you would like to solve, because that will tell you the modality. Is that text? Is that image? Is that audio? Is that video? So what kind of data you have? Do you have tabular data, or do you have free formatted text, right? Yeah, that perfectly covers it. We have to think about what is our point of interest, and after choosing that, for example, I would like to detect cars on a parking lot from the camera above the parking lot. So so here we can think about object detection. So we can treat a frame of the image of the video, a frame of the video as the image, and on that image we can figure out where the cars are. So you have to mark few images with cars being parked on the parking lot, and you train the model, and model starts detecting those cars automatically from each frame of the video. If you have,
Can I small interruption, because now I understand what you are getting at, but it just reminded me to actually I want to rephrase the question, because let's say that's actually a great example. I want to create this system for detection, and you need to mark your images, so basically prepare a data set manually. What is the best way to find tooling for that? Because, if I would have to prepare a dataset manually, I would like to separately find thousands of pictures and then separately open them up, maybe in some sort of software or a script that will display an image, and I can just mark everything I want, next, mark next. So if you personally are starting on solving a problem like this, do you create your own tools, or do you have some sort of top quality tool belt that is available for everyone? Like, if you want to train a model for visual stuff, here is your tool belt. If you want to teach that, here is your script.
You can show my screen. Right now, if you told me, Piotr, go and annotate some data, I would spin up Label Studio, which is open source platform that allows you to do any sort of modality. So basically within that, you got, for example, templates here, and this is just perfect also from the perspective of what we were talking about. So let's say that from computer vision, we would like to do OCR labeling for PDFs or optical character recognition at all, or we would like to do object detection with bounding boxes. Yeah, so we just click, and you can open the image. You can do the bounding boxes. You can just literally click that link and open the Label Studio with all the information. It is storing all necessary data automatically in the results of that annotation. And you can also do some modified, rotated, or you can do something like that. So let's say that I would like to annotate a plane, and I just annotated a plane. I would like to annotate a car, and I just have annotated a car. And
That's exactly what I was asking about.
Yeah, and here, like, next one. And like literally you can see that I just have annotated 3 planes and 2 cars on that image live with you.
And for those people who think that, oh, but this is just one picture, not really. I would say that this is actually 15 pictures, because most of the pre-processing pipelines for training models will take this picture, will basically include all of the markings, and then crop it, scale it, skew it, rotate it, flip it, whatever, like modify the image to augment this one picture into, let's say, 10 data points.
Additionally, we have multiple samples of the object.
Oh yeah, so that would be one of, like, a great example to start teaching model.
So the configuration of that is really simple. You are literally creating such a thing. You are creating a view. You are annotating an image.
My React sense is tingling. Is it written in React?
It is tingling properly.
Wait, really? It's in React?
It is some sort. Yeah, it is kind of like, that's a template for Label Studio, but I think the overall convention, yeah, it's
nice.
it.
Infinite said that's a nice explanation, Piotr, and yeah, that's actually a great explanation, and also a great tool, because I took a peek on the left side. Do they also have a natural language processing? Do they also have audio?
Yeah, like for computer vision, you have that image classification, multi-image classification, inventory tracking, even from computer vision. In natural language processing, name entity recognition, sentiment analysis, taxonomy, text summarization, machine translation, question answering. Those are the basic tasks.
You know
right?
what? To all of the people listening now, that's your homework. And by your homework, I mean, Piotr, can you show the URL or like the name of the tool?
Of course, I'm coming.
So that's a Label Studio. I'm quite excited that I don't see a tab called pricing, so I assume it's open source. Yeah, that's open source. Great.
Yeah,
so
it's open.
That's what I think I'm gonna do as well. Go through the docs and go through all of those examples to see how this tool allows you to prepare data, because you will understand, like, just from seeing how Piotr marked the planes and the cars in one image, that's basically what the model will end up doing. Mm-hmm. So what Piotr did is basically he put himself in the shoes of a model that will be then marking planes and cars. Mm-hmm. And you as a user or as a engineer will understand how this data needs to be formatted, how what will be the problems of model recognizing those things.
Mhm.
You will get more intimate with the data set. And this is actually what Piotr said at the very beginning of our conversation. This is actually what the data engineering is.
Mhm.
You have the data and you approach the data with the engineering mindset, meaning what the model will need from that data, how the data should be processed, how the data should look like.
Mhm.
So yeah, that's what I will do. Going to Label Studio, opening docs and going through the examples because, for instance, I don't really understand how I would process audio samples. Can we actually get there, like docs and
Templates of
yeah?
Oh, you see there's a lot more. There's even videos, time series analysis, structured
So
data.
let's go back to our LLM example. Maybe audio maybe is out of the scope for now. Maybe let's say the question answering. That's a nice template. Second, yeah, exactly. Interactive template preview.
Yeah, it is just the sample where the data will be
Okay.
on the interface. But this is kind of it. You have the answer, and you are highlighting like the definition of the what's going on, and you are creating here a question. How can black holes be detected? Even horizon has enormous effect on the fate of the object crossing it.
Damn, that's a great website to. I feel like this would be a best place to start with training own models.
And in terms of LLMs, I would also recommend this one. This is Unsloth. This is the software that is also available free of charge. They are providing a lot of models in a format that you are able to run on your notebook or phone, because they're basically getting the models from the creators and making the quantized version on their own.
Wait a minute, is it Unsloth? Didn't they release the Inkling?
No. They converted the thinking machines created Inkling.
Ah, right.
But Unsloth created GGUFs for Inkling.
Right. Okay.
And a lot of people or companies are doing something like that. But what they did, they provided a software that allows you to even click out the whole training process. So they have a possibility they give you possibility to literally choose a model from a dropdown, get some data set from Hugging Face or upload your own file, select the parameters, so the settings of your training, and literally just click start training. And
Nice.
later, you are able to run this model in chat, even in side-by-side comparison with the base model and the model that was fine-tuned by you. So you will see how the answer differs. And what's more, they not only provide that Unsloth Studio, and you see they are providing all of that magical latest news, but within Docs, they are providing all the information for latest models. Oh, wait a moment. Within Docs, once again, they are providing instructions how to run or how to fine-tune all of those models. So, for example, if you would like to fine-tune Qwen, yeah, or run them locally, or do the fine-tuning, here you have all the instructions. And and to train, you can see to train Qwen 3.6, you can refer to our previous Qwen 3.5 fine-tuning guide. And if you go here, you can see Qwen 3.5 and the fine-tuning guide here. And this is literally step by step.
Wow.
Update the Unsloth Studio. They are providing you notebooks and also all the information that is needed. A quick start. So here, literally step by step, install the Unsloth Studio, launch it, and train, and monitor training process and how that can be done. Later, you can export that fine-tune model, and you can just load it. You can export
And it's all
it.
locally.
Yeah.
Wow. Okay, let me show back my screen because you actually responded exactly to my next question, so I wrote it down already. If I have a weekend and a GPU, what should I try? So try Label Studio for data prep and try Unsloth for actual training.
Yeah, Label Studio for multiple problems like computer vision, natural language processing, audio processing, video processing, structured data, all of those. Label Studio also allows you to kind of train the model and evaluate it. And Unsloth is for LLMs.
Okay. So LLMs, overall data prep. Out of context might be vague, but with the context, I think it makes sense. So Label Studio, data prep, plus they have some tools for also actual training. I'm actually kind of surprised that you didn't mention things like, TensorFlow or Keras or, those big, huge frameworks.
Yes,
so
like PyTorch, Transformers, all of that. Basically, Unsloth is utilizing Transformers and PyTorch.
So it's visual GUI for PyTorch. Okay.
Exactly. If you dig deeper into, for example, not Unsloth Studio, which is a graphical user interface, but if you open those notebooks, which is basically a Jupyter notebooks with Python code, you will see that it is literally importing transformers. It is literally importing Torch.
Okay. So in full honesty, that's what put me away from learning how to train models back in the day, because I was not only starting with not understanding any math or Python or whatever. So that was a deep dive for me. So if I would have the Label Studio and Unsloth back then, I think I would still be my skills would be a little bit better. So those two great recommendations.
Your skills, Kevin, are very good.
Oh no, that's just pretending. I'm very good at pretending I know what I'm saying. That's, what, we are coming close to an end. If you have a little bit more time, let's finish up in that way. Will synthetic data?
We started with news from AI World blog and got little carried on.
So, in order to quickly explain to people watching what is the synthetic data, synthetic data is basically, imagine you have a car, a Tesla, right? And you want to teach Tesla how to drive through, I don't know, a jungle. There are not really a lot of videos of cars going through jungles, but there's enough videos of cars driving through jungles to create a stable diffusion, let's say, model that will generate videos of cars going through jungles. So basically, synthetic data is a data set created by AI. Of course, it has downsides. In example I gave, a car driving like that might not really move in a very realistic way, maybe. So it depends on the training purposes. But I've seen a couple of companies that grew large from preparing synthetic data sets because they're good enough to start. And like they're augmenting data sets, right? So do you think it will replace human data at any point, or it would rather always be an extension?
Synthetic data can be an extension to the real data that can mimic it, but it once again comes to a very important problem. I mean, we need proper data to do the task, and usually if one is an expert in a task, that knowledge is needed. But it is harder and harder to get that knowledge due to the fact that the contents that you
Showing
see,
back your screen.
yes, you can show it. The contents that you witness in the internet, for example, if you would like to get some data from the internet, so we went to the point where you can see AI generated content went beyond amount of content created by humans.
I see a little bit of content moderation starting to happen for a moment. Well, that's sad, but yeah, this will only degrade in quality.
It's harder and harder to get good quality data. So usually the data that you create on your own is the best one, or if you utilized the data sets that are properly and in detailed described
You know
where
what?
the data is from and what it is.
I consider it a very sad reality that we used to have the greatest data set ever called the internet. And we created AI and we treated publication of AI very irresponsibly. And because of that, we lost access to the greatest data set ever, because I think that now it's barely like I think it's impossible to actually extract any useful data from internet now without actually inhaling slop into your data set and feeding the model fake data. It's something's wrong there, right? There are some data points like baked in that will degrade the quality.
Yeah, and why I presented that, and you just literally read my mind, Kevin. The thing is that right now human data is the best source of knowledge, and any sort of synthetic data, of course it depends from the task, but usually any sort of synthetic data is not that good. And if we generate the data artificially, that data carries on that data that
I would say that this data will never breach.
Yeah.
I would say that this data will never breach the uncanny valley, but not uncanny valley in terms of, oh, this face is a little bit wonky. There is overall something wonky. Physics of generated videos, or
from mathematical physics, computer science point of view, if you create the data that may be good or may be wrong, you are basically carrying on the error.
Yeah.
So what happens here? You are propagating the error to the model of yours if you are training it on artificial data.
To give one of my, again, an example or a metaphor, if you would just blindly start creating data set, like synthetic data sets to teach new visual models how to generate images, and you would start using at some point only synthetic data that you are not scanning properly and you are not properly categorizing and fixing and improving, at some point all of your characters will have 7 fingers and 3 hands, because the error will get bigger and bigger and bigger and bigger, and errors created by one model will get picked up one way or the other by the next model, and then so on. So yeah, let's call it, it's just a gradient degrade. So let's just say nah. Just a simple nah. And second to last questions. Are we running out of training data? It's very related to this.
Probably very related to the thing I presented a moment ago.
Yeah.
Yeah.
Yeah. So here's nah, here's yeah.
That was quick.
And the last question. If somebody watching this stream wants to truly understand AI, what's the first thing they should build this weekend or do this weekend?
NanoGPT.
We can both have a go. Yeah, that is. I want to say exactly the same thing. Depending on the level of understanding, first, videos from Andrej Karpathy. Once you go through the videos, go through the projects on his GitHub, and if you finish that, start applying your knowledge in Kaggle, maybe, or start a small project by yourself. Create, I don't know, fetch Stable Diffusion and create a LoRa to generate images of your favorite pet. And yes, I know you can do this with a great level of success by asking GPT, for instance, to generate, like, give him an image and he will generate it, or Nano Banana or whatever is fancy right now. But it's all about understanding, right? So as a finishing thought, I think that we are starting to reach a level where everybody, including your grandparents and grandparents, everybody is able to use AI. But what differs between those who use AI is, do they actually understand what's happening? Do they understand the weight of the tool they are using? And what are the limitations? What is the purpose of the tool they are using? And the best way to understand those tools is not to use the, out-of-the-box solutions that we get from all of those companies. It's to sit down, break it down, make your own, figure it out. Because coming back to the thing I said last time, so many people, like everyone, is using LLMs. I think that maybe 5 to 10% of these people are able to explain what a token is. And everyone's like, oh, tokens are getting expensive. And they don't know what a token is. And they think that token is a currency that you give to a model. Let me share your screen again.
And if you take a look at the sources, at the guides that Kevin mentioned, you can, and you are really interested into it, there's a PyTorch beginner series, officially by PyTorch on YouTube. And don't worry, I know that it is 5 years old, but yeah, you can see that you can see that it was released on April 16, 2021. But nothing changed right now.
Yeah.
Only the architectures, only the way we manipulate data, coming back to data engineering, that changed. But the whole basics, how to build the model, how the fundamentals of gradients and everything are working.
It's basically, if somebody would like to learn how to draw, you are basically now showing a course how to draw shapes. And don't worry, shapes didn't change. They are still the same shapes, and you can still build everything with those shapes. If I could add one thing to what would be nice to learn, and I'm really mad at myself that I learned this so late. Learn some math. Like I'm not a mathematician. I'm not very good with maths. But I understand if somebody would say gradient descent or linear or logarithmic, function, like understanding the idea, the concept, I feel like this gives you a huge heads up. So yeah, I would go with math. Henry Karpathy, and play around with shit. Just run the model locally, and once you run the model locally and play around with that, remove Olama, and try running it using inference like straight from PyTorch, or go lower and lower and lower to understand how things work. And I think that's the best way to learn. And also,
and the physics is probably the only limitation here. We can get down to the level of how the paths on the GPU are being laid, and
yeah, exactly. So I would also ask myself, what do I actually want from that? Because when I started doing a deep dive into trying to learn AI, at some point, like it hit me that I will never be as smart as people who are actually creating architectures of those models, and I will never reach that level because I started too late. But I wanted to know enough to be able to work with this technology, to talk about this technology, to discuss this technology with Piotr and get excited and be hyped for new technology. And when somebody says that, oh, this new model uses a new level of quantization that has just one bit, that, oh, I can get excited because it sounds fun, and not just, what is quantization? So does it speak English? I mean, yeah, it does. So yeah, ask yourself, what do you want to learn? Why do you want to learn? And start doing things. And with that, those positive things, Piotr, do you think we should finish here? like we overextended a little bit the stream, but I had so much fun, just wanted to finish up.
I just want to say that it's never too late to start, and that train is still to catch.
Oh, maybe.
Yeah.
Once the models are finally starting to get into reach of a single person. Like I'd give it 2 to 5 years, 2 to 3 years. The models will get so small, but still so good that everyone would be like, it would be in a realm of possibility to become Tony Stark and creating your own super intelligence that aids you in everyday tasks, because the model will be small, fast, efficient, and you will be paying for it only the same amount you pay for energy. And like the customizability of how it behaves and what it does and stuff like that. So yeah, people, start learning. This would be such a great moment to like insert sponsored by and some learning platform. But yeah, maybe one day. And with that, Piotr, I think we can finish up. So let me put a slow background. That's the music. Yes, that's the finishing music. Piotr, thank you so much for the stream. We got one WTF in the comment section. I'm not sure if the WTF is about us finishing or about my final speech. But yeah.
But I totally agree with you, Kevin. You couldn't wrap this up better. I also think that in general, that AI that should assist us will become more and more available for all of the people. And at this very moment, we are witnessing the miniaturization of intelligence, and that is something to watch.
Yeah, like for a very long time, when AI started to become a thing, I really started thinking that, oh, it doesn't really matter if I learn that or not, because AI can just like figure it out for me. And this is partially true, but in order to control AI tools, you need to have an intent. In order to have an intent, you need to have an understanding of what you want to achieve or what do you want to do. And those two things is not something that AI will generate for you. So yeah, go out there, start learning, start playing with things. Piotr, thank you so much for streaming with me today. I again had so much fun. I'm looking forward to streaming with you again sometime in the future. Maybe we will actually make it a reality to make a learning resource that will be at least half good as what Andrej Karpathy does, but maybe we'll focus on other things, go more in depth. But that's for the future. For now,
it was pure pleasure to be here with you today.
Thank you so much for that. So yeah, Piotr, have a nice day. Y'all have a great day. Infinity, thank you for commenting. Juan, thank you for being here. Gregor, thank you. Ryan, thank you. And Feet Tarek, I'm not sure what the WTF was for, but I hope you got your answers as well. If you want, all of that stream was, of course, recorded. It will be shared on YouTube's. So if you are late, you can just rewind, basically, and skip to your favorite parts. But that's all. So thank you for being here. Thank you for listening.
We managed to finish that map.
Yes. we finished the entire road. Maybe I will somehow like prepare that and share it on Access or stuff like that. So be on the lookout for it. And with that being said, see y'all in 2 weeks. In 2 weeks, we'll be having a discussion about, I don't even know, but I will be informing you. And this will be an interesting topic. Yes, because I need to still schedule with a guest to actually discuss what we want to share. But yeah, I don't want to keep you longer. Thank you all. Have a great day. See you in the future soon. Yeah. Bye-bye.